Hello students, welcome to Inside Physics. In this session, we will discuss Bohr's model of hydrogen atom. How Bohr could able to explain the atom and its revolving electrons, what is the basis behind it. So how the structure of atom is elaborated by Bohr, we will discuss here. Prior to Bohr, there was Rutherford who predicted the planetary model of the atom. So as per that system model, the electrons are revolving around the nucleus as per the planets revolve around the sun. So in the planetary system, gravitational force is the binding force between the sun and planets. So here the electric force between protons and electrons is the binding force. But Rutherford's model has some lapses. So it could not explain the stability of the atom. Why? Because as per we know classical electromagnetic theory, any particle revolving in a circular orbit will be under the acceleration like centripetal acceleration, and any accelerated charged particle will continuously emit energy as per classical electromagnetic theory. So electromagnetic wave theory proposes the continuous emission of radiation for a charged particle which is being accelerated. In a circular orbit, if an electron is moving in a circular orbit, we can also say that the electron is under an effect of acceleration that is towards the center of the circle, that is called centripetal acceleration, and also it is experiencing the centripetal force. So the force is between the central positive charge, that is protons, and revolving electron. So here the classical electromagnetic theory could not explain the behavior of the electron, which is very stable and non-radiating in a revolving orbit. As per electromagnetic theory, if the electron is continuously emitting radiation while moving in a circular orbit, it must be coming into the nucleus and finally it will fall into the nucleus emitting radiation, and so that by radiating its energy, the angular velocity is also will be decreasing, and also the frequency of radiation. As per this electromagnetic theory, the frequency of emitted radiation of an electron is nothing but the number of revolutions, the frequency of the electron around the nucleus, number of revolutions per second, that is equivalent to the emitted energy frequency. So in these two postulates, the stability of the atom could not be explained by Rutherford. So in this scenario, Bohr explained this very well, and from 1985 to 1962, the Bohr era, 1885 to 1962. So in this period, he actually worked some days in the laboratories of Rutherford, and actually he finally could able to explain the stability of the atom on the basis of latest quantum principles, where in those days the quantum theory was developing, and the principles of quantum theory he used to explain the stability of the atom. In this scenario, he proposed three postulates. Before that, we actually see that whenever an electron is continuously emitting radiation as per electromagnetic theory, which could not explain the stability of the atom, whenever the electron is in the circular orbit rotating, so it almost finally the rotation will come and it end at the nucleus like this. So in this process, the angular velocities and the frequency will also change because it is continuously moving into the radius while doing the circular orbit. So here the emission of radiation and is continuous as per that electromagnetic wave theory, but the actual observed spectrum of an atom is not continuous, it is line spectrum. So in this scenario also, Rutherford model could not explain the proper justification for line spectrum. Okay, so we see what are the three postulates of Bohr model. The first one is, as per Bohr model, the electron will be rotating in a circular orbit around the nucleus, and that particular orbit is a non-radiating orbit. That means the electron doesn't radiate any energy while rotating around the nucleus. So that non-radiating orbits are also called the states of the atom. Okay, we call it the ground state, first state, like that. So these states, the stationary orbits which are non-radiating, means the electron doesn't emit any energy while rotating in the orbits. So this is the first postulate, that is regarding non-radiating orbits. Okay, so how these orbits will be? The orbits are decided in such a way, the angular momentum of the electron L is integral multiple of h by 2 pi. This is the second postulate in Bohr model. The orbit so decided in which the electron is moving continuously in a circular orbit, for that particular orbit the angular momentum of the electron is integral multiple of h by 2 pi. So that in that scenario we can write it as nh by 2 pi, where n is the integer. 1 from n begins from 1, 2 and 3 and so on, where 1 means the first orbit, the ground state. Okay, so this is the second postulate. Generally angular momentum is written as mvr, mass into velocity into radius of the circular orbit. Okay, next one, the third postulate, very important and interesting postulate. Whenever an electron jumps from one non-radiating orbit to the other orbit, that means from higher energy to the lower energy. So see, whenever there are orbits continuously around the nucleus, the first orbit, see, as per the energy of an electron revolving around the nucleus, in the previous classes we have studied this as per the formula. Okay, so minus means the energy is binding energy, so E square by 8 pi epsilon naught r. So here whenever we call this angular momentum is conserved, that means here we can equate the angular momentum with the second postulate of Bohr, that is nh by 2 pi. Okay, if you equate these two, what we get? mvr is equal to nh by 2 pi. You can write it as, in general form, when you consider more than one orbit is there in the atom, you can write it as nh by 2 pi. So V and Rn are the velocity of an electron in nth orbit and radius of the nth orbit. So mass is always constant. In a general form you can write like this. Okay, so by these relations we can find out the velocity of an electron in a particular orbit, and for that we use the equation of Bohr radius. See, the radius of the orbiting electron, we have already calculated this one in the previous sessions. This will be equal to 4 pi epsilon naught mv square. Okay, so this is the radius. As per the electron revolution and its velocity, we will decide the radius of the orbit. So this is how we proceed in calculation of radius, and now we will calculate the velocity. See, velocity as per this Vn, right? Vn is equal to, see this I will take nh by 2 pi, nh by 2 pi, this mRn goes this side. Okay, so now we place this value here, this entire Rn value here at this place. Okay, if you do like that, we will get the Vn value after simplification. The Vn value will be, after simplification, we get E by root of 4 pi epsilon naught mRn. So this is the charge of electron. Okay, so whenever you put Rn value here, after simplification, you will get the velocity of the electron which is revolving in the nth orbit. So in the same sense, we can also calculate Rn. How you do that? See, putting this value here, you can take it as Vn. Putting this value here in the place of Vn, you will get the value of Rn. That means radius of the Bohr orbit, or the orbit whichever we take, first one, second one, third one. So if you place one here, that is the first orbit. So that value we will also get it by substituting Bn in place of so n square by m h by 2 pi whole square, n square by m h by 2 pi whole square, 4 pi epsilon naught by e square, 4 pi epsilon naught by e square. So this is, I have written it directly, so you can do the simplification parts. It's a simple mathematics. So we already derived velocity of an electron and radius of the nth orbit in this way. Okay, so Vn and Rn. What about the energy? The energy of an electron, which is the energy of the orbit. See, the energy of an electron is equivalent to the energy of the orbit itself. So there is nothing like the orbit is having some energy. It is the electron which is revolving in that orbit and having that particular energy. In that sense, we can write En. Means, how you get this one? Previously we have derived one equation R, right? In place of R, you can put it as N. So Rn value you place here. See, this is Rn, you place here, then you will get the energy formula. So I will do directly, I will write the formula. Minus e square by 8 pi epsilon naught m by n square two pi by h whole square into e square by 4 pi epsilon naught. Okay, so this is the value we got whenever we tried to calculate the energy level of the particular radiating, non-radiating orbit. Okay, by simplifying this, what we will get? By simplifying this, we will get minus m e power 4 8 n square epsilon naught square h square. So this is the energy equation we got. Okay. So by substituting the values, the mass of the electron, charge of the electron, epsilon naught value, that means permittivity of free space, h value, Planck's constant, and the n value, if it is for first orbit, we put it as 1. In general, what you will get? In general, when you substitute all these values, you will get minus 2.18 into 10 to the power of 18 by n square joules. Minus 2.18 into 10 to the power of minus 18 by n square joules. This is the energy of an orbit or revolving electron which is moving in nth orbit. So by substituting, if you want to convert the energy into electron volts, what you need to do? This is in joules. If you want to convert it into electron volts, okay, so we will do, we know that 1 electron volt is equal to 1.602 into 10 to the power of minus 19 joules. Okay, so to convert this into electron, after converting this into electron volts, what happens? How we will do this? So you just simply divide this one with this value, you will get that into electron volts. Then what is the final value in electron volts? The final value will be minus 13.6 by n square electron volts. So this is a very famous derivation done by Bohr to estimate the energy of the particular orbits, non-radiating orbits. This is the number which is given to the Bohr orbits. Okay, whenever we call it as if we take it as a hydrogen atom, it has only one orbit, that is the ground state, that means the first orbit of the hydrogen atom. And see, the energy will be calculated as per this rule. Okay, this is about the model, Bohr model of hydrogen atom. See, this energy, whatever we have calculated here, the assumption that electronic circular orbits, though orbits are under inverse square force. See, here in this derivations, what we assume is these are all circular orbits. As per these formulas, energy formulas, the orbits are circular orbits. But as per the observations in practical, the force, whenever the force is inversely proportional to square of the distance between the objects, that kind of force will actually making the objects revolve in an elliptical orbit. But as per the observations, these formulas will also work out for the elliptical orbits, not only circular orbits. In general, as per the derivation, we assume that these derivations are for circular orbits. That's why we assume that the orbits in an atom in which electrons are revolving are circular. So this is the theory of Bohr's model of hydrogen atom. In the next session, we will take up one more interesting topic.